inside the Earth. 7. What is a satellite? Struggling to pass Class 11 Physics? Don't worry. Smart Tricks for Study presents the ultimate 2026 passing package. We have selected the most repeated and revised chapter-wise to mark questions that appear in your final exams 2026. For PDF, just join our Telegram channel. Don't forget to subscribe the channel. Let's start. Chapter 1. Units and Measurement. 1. Name to supplementary units in SI system. 2. Mention the application of dimension analysis. 3. What are basic units? Give one example. 4. Write the SI unit and dimensional formula for moment of inertia. 5. State the principle of homogeneity of dimensions. 6. Give any two limitations of dimensional method. Chapter 2. Motion in a straight line. 1. Write any two differences between instantaneous speed and instantaneous velocity. 2. Draw a position time graph for a body moving with constant speed. 3. Draw a position time graph for a body moving in positive direction with negative acceleration. 4. Define average velocity and uniform velocity. 5. A body moving with an initial velocity 5 meters per second and uniform acceleration 1 meter per second square. Determine its velocity after 20 seconds. Answer is 25 meters per second. Chapter 3. Motion in a plane. 1. Define scalar product of two vectors. Give an example for scalar product of vector. 2. Write the expression for resultant of two concurrent vectors A and B and explain the terms. 3. Write the expression for time of flight of a projectile motion and explain the terms. 4. Write the expression for range of a projectile and explain the terms. 5. Write the expression for centripetal acceleration and explain the terms. 6. Explain the triangle method of vector addition. 7. Write the equation for the trajectory, path, of a projectile motion. What is the nature of its trajectory? Chapter 4. Laws of motion. 1. Name the two physical quantities which are defined on the basis of Newton's first law. 2. Write the expression for momentum in vector form and explain the terms. 3. Mention the SI unit and dimensional formula of momentum. 4. Distinguish between mass and weight of a body. 5. Write Newton's second law in component form. 6. State and explain Newton's first or second law of motion. 7. Mention the significance of component form of Newton's second law. 8. What is an impulsive force? Give example. 9. Define impulse of a force with an example. 10. State and explain Newton's third law of motion. 11. Give an example which illustrates the law of conservation of linear momentum. 12. State the principle of rocket propulsion. 13. Mention the common forces in mechanics. 14. What are normal reaction and friction? 15. What are contact forces? Give examples for contact forces in mechanics. 16. Mention the types of friction. 17. Mention the advantages of friction. 18. Name the types of kinetic friction. 19. What is sliding friction? Give example. 20. What is rolling friction? Give example. 21. What is banking of roads? Why banking is necessary for a curved road? 22. A body of mass 1.5 kilograms has linear moment of 6 kg ms1. Find its linear velocity. 4 ms1. 23. A 10 kilograms object accelerates at 2 meters per second square. What is the magnitude of the force? Answer is 20 Newton. 24. A constant force of 8 Newton is applied to a body of mass 3 kilograms. Find the acceleration of the body. Answer is 2.66 meters per second square. Chapter 5. Work, power and energy. 1. Mention the necessary conditions for work done. 2. State the conditions under which no work is done. Or write the conditions for zero work done. 3. Under what conditions the work done by a force is maximum and minimum. 4. Can acceleration be produced without doing any work? Give example. 5. Write the SI unit and dimensional formula of work. 6. What are conservative and non-conservative forces? Give example. 7. Mention the SI unit of energy and write its dimensional formula. 8. Name the types of mechanical energy. 9. Define kinetic energy of a body. Give examples. 10. Define potential energy. Give examples. 11. State and explain force law for the spring. 12. What is a spring constant of a spring? Give its SI unit. 13. Draw a graph of variation of kinetic energy and potential energy of a block attached to a vibrating spring which obeys Hooke's law. 14. Mention the different forms of energy. 15. What is the unit of electrical energy? Express it in joules. 16. Which physical quantity is measured in HP? Express it in SI units. 17. Write the SI unit and dimensional formula of power. 18. What is elastic collision? Give examples. 19. What is inelastic collision? Give examples. 20. Distinguish between elastic collision and inelastic collision. 21. A constant force of 8 Newton is applied to a body which displaces it through a distance of 9 meters in the direction of the applied force. Find the work done by the force. Answer is 72 joules. 22. An object of mass 10 kilograms is moving with speed 5 meters per second. Estimate the kinetic energy associated with the object. Answer is 125 joules. 23. Derive an expression for power in terms of force and velocity or show that P is equal to F, V. Chapter 6. System of particles and rigid body. 1. What is the pure translational motion? Give one example. 2. What is the pure rotational motion? Give one example. 3. Give an example for a body whose center of mass lies 1. Inside the body and 2. Outside the body. 4. What is mechanical advantage of a lever? The mechanical advantage of a lever is greater than 1. What does it mean? 5. Define vector product of two vectors. Give an example. 6. Define moment of force. Write the expression for it. 7. Mention the two factors on which torque of a rotating body depends. 8. Define angular momentum. Write the expression for it. 9. Write the dimension and SI unit of angular momentum. 10. State and explain the principle of conservation of angular momentum. 11. Write any two examples for conservation of angular momentum. 12. Define moment of inertia of a particle. Write its SI unit. 13. Mention two factors on which moment of inertia of a rigid body depends. 14. Define couple. Give the expression for moment of couple. 15. Give two examples for couple. 16. State the principle of moments. What is mechanical advantage? 17. Give the general conditions of equilibrium of a rigid body. 18. Why a flywheel is used in engines of vehicles. 19. What are the factors on which the moment of inertia of a body depends? 20. To maintain a rotor at a uniform angular speed of 200 per radians, an engine needs to transmit a torque of 180 Newton meters. What is the power required by the engine? Answer is 3600 watts. Chapter 7. Gravitation. 1. Moon has no atmosphere. Why? 2. Define gravitational potential energy of a body. Give an expression for it. 3. State and explain Newton's law of gravitation. 4. What is escape speed? Give its value in the case of Earth. 5. Define orbital speed of a satellite around the Earth. Write the expression for it. 6. Why does an object weigh more at the surface of Earth than at any point inside the Earth? 7. What is a satellite? Name the natural satellite of Earth. 8. Give any two applications of artificial satellites. 9. The both radius and mass of a planet are 2 times that of the Earth's values. Calculate the acceleration due to gravity on the surface of that planet. Answer is 4.9 meter per second square. 10. The radius of the Earth is r.e. Find the depth at which the acceleration due to gravity is half the acceleration due to gravity at the surface of the Earth. Answer is d is equal to r.e. by 2. Chapter 8. Mechanical properties of solid. 1. What do you mean by elasticity and plasticity? 2. Give one example each for elastic and plastic substance. 3. Define stress. Mention its SI unit. 4. Define strain. What is its unit? 5. State and explain Hooke's law. 6. Define 1. Compressive stress and 2. Tensile stress. 7. Define 1. Shearing stress and 2. Hydraulic stress. 8. Define longitudinal strain. Write the expression for it. 9. Define shearing strain. Write an expression for it. 10. Define volume strain. Write an expression for it. 11. What is yield point? Define yield strength of a material. 12. What are elastomers? Give an example. 13. Draw stress-strain curve for an elastomer. 14. Write the expression for Young's modulus. Explain the terms. 15. Write the expression for rigidity modulus of the material. Explain the terms. 16. Mention the expression for bulk modulus of the material. Explain the terms. 17. Write to application of elastic behavior of the material. 18. Define compressibility. Mention its SI unit. 19. Define Poisson ratio. Give an example for it. 20. Write the expression for the buckling sag of a beam that is supported at its two ends and is loaded at the center. Explain the terms. 21. A steel rod of area of cross-section 3.14 into 10 to the power minus 4 meter square is stretched by a force of 100 kN. Calculate the stress acting on the rod. Answer is 3.2 into 10 to the power 8 Pascal. 22. Calculate the fractional change in the volume of glass sphere when subjected to a hydraulic pressure of 1.013 into 10 to the power 6 Newton per square meter. Bulk modulus of glass is 3.7 into 10 to the power 10 Newton per square meter. Answer is 0.00 to 7%. 23. The bulk modulus of a material is 2 into 10 to the power 9 Pascal. What is its compressibility? Answer is 5 into 10 to the power 10 per Pascal. Chapter 9. Mechanical properties of fluid. 1. What are fluids? Give an example. 2. Define pressure. Write its unit. 3. Define 1. Density and 2. Relative density. 4. Write the equation for gauge pressure and explain the terms. 5. Write the expression for absolute pressure and explain the terms. 6. State and explain Pascal's law. 7. Mention any two factors on which pressure inside a fluid depends. 8. Write the conversion factors of 1. 1 torr and 2. 1 bar into pascals. 9. In what fields the units torr and bar are used to measure pressure? 10. What is the use of a 1. Mercury barometer and 2. Open tube manometer? 11. Write any two applications of Pascal's law. 12. What is streamline motion? Give an example. 13. What is turbulent motion? Give an example. 14. What are the limitations of Bernoulli's equation? 15. Write any two applications of Bernoulli's principle. 16. What are 1. Dynamic lift and 2. Magnus effect? 17. What is viscosity? Write the expression for coefficient of viscosity. 18. Write the SI unit and dimensional formula for coefficient of viscosity. 19. State Stokes' law. Write the expression for the viscous drag force on a spherical object moving through a fluid. 20. What are the factors on which drag force on an object moving through a fluid depends? 21. Define the terms 1. Surface energy and 2. Surface tension. 22. 1. Why are drops and bubbles spherical in shape? 2. Why are detergents used as wetting agents? 23. Write the expression for capillary rise inside a capillary tube. Explain the terms. 24. Mention the expressions for excess pressure inside 1. A drop and 2. A bubble. These are some problems on this topic. Next. Chapter 10. Thermal properties of matter. 1. Write any two differences between heat and temperature. 2. What are two fixed points on a temperature scale? 3. Draw a graph of Fahrenheit temperature versus Celsius temperature. 4. State and explain Boyle's law. 5. State and explain Chaillet's law at constant pressure. 6. Draw a graph of pressure versus temperature for low-density gases indicates the same absolute zero temperature. 7. Define coefficient of linear expansion of a solid. Mention its SI unit. 8. Explain the meaning of the statement, the coefficient of linear expansion of silver is 0.000019 per Kelvin. 9. Define coefficient of volume expansion of a solid. Write the expression for it. 10. What is meant by anomalous expansion of water? 11. Explain the variation of volume of 1 kg of water with temperature graphically. 12. At what temperature, the density of water is maximum? Mention the highest value of density of water. 13. Name any two substances which neither expand nor contract on heating. 14. Define heat capacity of a substance. Write its SI unit. 15. Define specific heat capacity of a substance. Write its SI unit. 16. Define 1. Molar specific heat of a gas at constant volume and 2. Molar specific heat at constant pressure. 17. Cp is always greater than Cv. Why? 18. Mention the factors on which molar specific heats depend. 19. State and explain the principle of calorimetry. 20. Define the terms 1. Melting and 2. Fusion. 21. Define the terms 1. Vaporization and 2. Sublimation. 22. Define the terms 1. Melting point and 2. Normal melting point. 23. What is regulation? Mention one of its practical applications. 24. Explain the possibility of ice skating. 25. Define the terms 1. Boiling point and 2. Normal boiling point of a liquid. 26. Define latent heat of substance. Give its SI unit. 27. Define the terms 1. Latent heat of fusion and 2. Latent heat of vaporization. 28. Define coefficient of thermal conductivity. Mention its SI unit. 29. Why a metal bar does feel much colder than a wooden block on a cold day. 30. What are the values of thermal conductivity of A? 1. A perfect heat conductor and 2. A perfect heat insulator. 31. Mention the types of convection. 32. Distinguish between conduction and convection. 33. State and explain Stefan-Boltzmann law of radiation. 34. State and explain Wien's displacement law of radiation. 35. State and explain Newton's law of cooling. 36. Convert 100 degree F into degree Celsius scale. Next. Chapter 11. Thermodynamics. 1. Define the terms 1. Thermodynamic system and 2. Surrounding. 2. When is a system said to be in the state of thermodynamic equilibrium? Explain with example. 3. Define the terms 1. Adiabatic wall and 2. Diathermic wall. 4. State and explain zeroth law of thermodynamics. 5. Who formulated zeroth law of thermodynamics? Mention its significance. 6. What is the nature of internal energy of an ideal gas? Explain. 7. State and explain first law of thermodynamics. 8. Show the variation of specific heat capacity of water with temperature graphically. 9. Name the thermodynamic variables defined by 1. Zeroth law and 2. First law of thermodynamics. 10. What are thermodynamic state variables? Give an example. 11. Define the terms 1. Equilibrium state and 2. Equation of state. 12. Mention the types thermodynamic state variables. 13. What is an isothermal process? Give an example. 14. What do you mean by adiabatic process? Give an example. 15. What is isobaric process? Give an example. 16. What is isochoric process? Give an example. 17. Write the expression for work done by a gas in an isochoric process and explain the terms. 18. Write Kelvin-Planck statement and Clausius statement of second law of thermodynamics. 19. Define reversible process. Give an example. 20. Define irreversible process. Give an example. 21. Mention any two causes of irreversibility of a thermodynamic process. 22. State Carnot's theorem. Next. Chapter 12. Kinetic theory. 1. State and explain Avogadro's hypothesis. 2. Show that behavior of real gases approach ideal gas at low pressure and high temperature graphically. 3. Mention the expression for average kinetic energy of a gas molecule in terms of its absolute temperature. 4. Find the value of the ratio of specific heats for monoatomic gas molecule. 5. Find the value of the ratio of specific heats for rigid diatomic gas molecule. 6. Write the expression for the ratio of specific heats for polyatomic gas molecule. 7. Mention the factors on which the mean free path of a gas molecule depends. Chapter 13. Oscillations. 1. What is periodic motion? Give an example. 2. Define simple harmonic motion. Give an example. 3. Write any two characteristics of SHM. 4. Write the equation for displacement of a particle of a simple harmonic wave. Explain the terms. 5. Draw displacement time graph of a particle executing SHM. 6. Define the terms A, period B, frequency of periodic motion. 7. Define phase of a particle. In which quantities it is expressed. 8. Write the expression for time period of oscillations of simple pendulum and explain the terms used. 9. Mention the expression for the period of oscillation of a spring and explain the terms. 10. At which position is the acceleration of the particle executing SHM is maximum and minimum. Next. Here are some problems on oscillation. Chapter 14. Waves. 1. Mention any two applications of beats. 2. Distinguish between mechanical and non-mechanical waves. 3. What are beats? What is the principle of beats? 4. Mention the relation between wave frequency, wavelength and wave velocity. 5. The wave has wavelength 2 meters and frequency 0.5 Hz. Calculate the velocity of wave. Answer is, V is equal to 1 meter per second. 6. What is the wavelength of the wave traveling with velocity 3 meter per second having time period 0.5 second? Answer is, lambda is equal to 1.5 meter. In the next video we see 3 marks questions. Don't forget to subscribe the channel for more updates.